Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which evaluates an expression in a binary tree. First, let us take an example. We go from bottom to top while evaluating. As you can see, after evaluating, we get the final output which is 110 for the first tree and 100 for the second tree. Now, let us see the algorithm which will assist us in this. Let us also have a sample tree to test our algorithm. We pass the root node, which is the plus operator, to eval function. So, root will point to plus. Since root is not null, we move to the second if. We check if root is a leaf node. Since the plus operator has both left and right child, it is not a leaf node. So, we evaluate the left subtree recursively. We use a call stack for this. We pass the left child of plus, which is the multiply operator. So, root will now point to the multiply operator. Again, we check if root is null. Since it is not, we continue to the second if. Now, we check if root is a leaf node. Since the multiply sign has both left and right child, it is not a leaf node. Now we pass the left child of multiply operator, which is 5. So, root will now point to 5. We check if root is null. Since it is not, we check if it is a leaf node. Since 5 does not have any child, it is a leaf node. So, we return 5, which we first convert into an integer format and then return. So, lval will point to 5. We continue execution for the multiply operator. So now, we call the right subtree of the multiply sign. The right child is 4, so we pass 4 in the eval function. Hence, root will point to 4. Again, we check if root is null. As it is not, we check if root is a leaf node. Since 4 does not have any child, it is a leaf node. Hence, we return 4 converted into integer form. We continue execution for the multiply sign. Now we check which operator to apply. Since we have the multiply operator, we return lval into rval. So, 4 into 5, which is equal to 20, will be returned. We continue execution for the right subtree of the plus operator. So, the right child of plus, which is the minus sign, is called and root will point to the minus sign. We check if root is empty. Since it is not, we check if root is a leaf node or not. Since the minus sign has both left and right child, it is not a leaf node. So, we call the left subtree of the minus sign. The left child is 100, so 100 will be called. Since 100 is a leaf node, we return numeric 100 to lval for minus. We continue execution for rval for minus. So, 20, which is the right child of minus, is passed. Since 20 is a leaf node, we return numeric 20 to rval for minus. We continue execution for the minus sign. Now we check which operator to apply. Since root is minus, we return lval minus rval. So we return 100 minus 20, which is equal to 80, to our val of plus. We continue execution for the plus operator. Now we check which operator to apply. Since root is plus, we add lval and rval and return the sum of these two. So 80 plus 20, which is equal to 100, is returned. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in our tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.